Async await. Introduction. Often in web development, we need to handle asynchronous actions, actions we can wait on while moving to other tasks. We make requests to networks, databases, or any number of similar operations. JavaScript is non-blocking. Instead of stopping the execution of code while it waits, JavaScript uses an event loop, which allows it to efficiently execute other tasks while it awaits the completion of these asynchronous actions. Originally, JavaScript used callback functions to handle asynchronous actions. The problem with callbacks is that they encourage complexly nested code, which quickly becomes difficult to read, debug, and scale. With ES6, JavaScript integrated native promises, which allow us to write significantly more readable code. JavaScript is continually improving, and ES8 provides a new syntax for handling our asynchronous actions, async await. The async await syntax allows us to write asynchronous code that reads similarly to traditional synchronous imperative programs. The async await syntax is syntactic sugar. It doesn't introduce new functionality into the language, but rather introduces a new syntax for using promises and generators. Both of these were already built into the language. Despite this, async await powerfully improves the readability and scalability of our code. Let's learn how to use it. Instructions. 1. In this lesson, you'll be given a code editor to write your code and a bash terminal to execute your code. To execute your program, you'll type node app.js in the terminal and hit enter or return. You'll press the check work button to submit your code for evaluation. Check out the code we provided. It shows 3 ways to accomplish the same task: reading and printing from 2 files in a specified order. The first version uses callback functions. The second version uses native promise syntax. The third version uses async await. Let's take a quick look at this. They're importing the file system. Permissified file read is a different file they're requiring here as well. Here we use the file system read file and callback functions. Okay, file system read file. And then it will have error data, and then there's the callback function. Okay, I see what it's doing. It hands the read file method what it wants, and then it passes it this callback here with there can be an error or the data comes, and then it uses either if error, throw error, and if not, let first sentence equal that data that came back. And then it's going to file system.read file, another file, which has another callback, error data, and let second sentence, and then console log those 2 sentences. Here's the native promises with our promisified version of read file. They have promisified read file, and in the .then, this is exactly how we did it in the last lessons here. So .then, we'd hand pretty much anything we wanted to call it. We're going to call it data. First sentence will equal the data, and then it's going to return the promisified read file and read the second file, do another .then, and the second sentence, and then console log those 2 together. Here we use the permissified read file again, but instead of using the native promise.then syntax, we declare and invoke an async await function. Async function read files. Let first sentence equal await permissified file. Okay, and it passes in the file and the file type. And then let second sentence await permissified file read, and that's your second file and your second file type, which is the same. Then console.log both of them, and this looks absolutely the cleanest. So this is what we'll be learning today. Don't worry about understanding the async await syntax. That's what you'll learn in this session. If you haven't already, type node app.js in the terminal and press enter, then press check work. Node app.js enter. It does the same thing, all of them, and check work. We can go on to the next lesson. The async keyword. The async keyword is used to write functions that handle asynchronous actions. We wrap our asynchronous logic inside a function prepended with the async keyword. Then we invoke that function. Async function myfunc, and then the function body inside here, and then you can invoke myfunc as so. We'll be using async function declarations throughout this lesson, but we can also create async function expressions. Const myfunc equals async, and then it opens and closes parentheses because this is an arrow function and it points to an empty body. Then they invoke myfunc. Async functions always return a promise. This means we can use both traditional promise syntax like .then and .catch with our async functions. An async function will return in one of three ways. If there's nothing returned from the function, it will return a promise with a resolved value of undefined. If there's a non-promise value returned from that function, it will return a promise resolved to that value. If a promise is returned from the function, it will simply return that promise. We have async function 5 promise, and that function's body returns the number 5. Now below that is 5 promise invoked .then resolved value, and an arrow function console.log resolved value will print the number 5. In the example above, even though we returned 5 inside the function body, what's actually returned when we invoke 5 promise is a promise with a resolved value of 5. Let's write an async function. Instructions. 1. We provided a function with constructor which takes in a number. If a number is 0, it returns a promise that resolves to the string 0. If the number is not 0, it returns a promise that resolves to the string not 0. Take a moment to understand this function and the code that follows. When you're ready to run it, type node app.js in the terminal and press enter. So we see here that this is going to take in a number, and if the number triple equals 0, resolve has 0 attached to it, else resolve has not 0 attached to it here. So that's what our promise is doing. We have the resolve reject, and we have no way for this to be rejected inside of here. And with constructor, passes in 0, then it will take the resolve value in a arrow function in console.log with constructor, and what was in there, the number 0, returned a promise which resolved to, and then the resolve value, which in that case should be 0. Node app.js in here and enter. Constructor with constructor 0 returned a promise which resolved to 0. That worked as we thought it would. Let's move on to number 2. Write an async function with async, which reproduces the functionality of with constructor. Though your function will return a promise, it should not construct the promise using the new keyword. Instead, it should rely on the fact that an async function automatically returns a promise. When you're ready, check your work to move on to the next step. So they want us to do this right here. They want us to do this, the with constructor, and they want us to reproduce the functionality of with constructor. Okay, so we'd say async function with async. It's going to take in a number as an argument, num, and yeah, I think we just have to return it according to this here. If a promise is returned from the function, it will simply return that promise. Okay. Let's do that. So we need our if statement here just the same. So if num triple equals 0, return 0. We really shouldn't need to do it like that. Let's see if they say no to this. That should work perfectly. Return 0, else return not 0. return, not 0. All right, let's check that. That's working, great. 3. Now test your code. Uncomment the test code we wrote at the bottom of app.js. Oh, right over here. Okay, uncomment this. You know what? We got to just delete this part and this part. Okay. In the terminal, type node app.js and press enter to execute the code. Node app.js, enter. And we can see, yeah, there we are. Our with async should do the same work right here. So with async, 100 return to promise, which resolved to not 0. Perfect. Let's move on to, oh, we didn't check it. Let me check it. Okay, now we can move on to the next lesson. The await operator. In the last exercise, we covered the async keyword. By itself, it doesn't do much. Async functions are almost always used with the additional keyword, await, inside the function body. The await keyword can only be used inside an async function. Await is an operator. It returns the resolved value of a promise. Since promises resolve in an indeterminate amount of time, await halts or pauses the execution of our async function until a given promise is resolved. In most situations, we're dealing with promises that were returned from functions. Generally, these functions are through a library, and in this lesson, we'll be providing them. We can await the resolution of the promise it returns inside an async function. In the example below, myPromise is a function that returns a promise which will resolve to the string I am resolved now. Async function, async func example. Inside of the asynchronous function example is a body that has let resolved value equal await myPromise as a function. Console.log resolved value. Async func example invoked prints I am resolved now. Within our async function, async func example, we use await to halt our execution until myPromise is resolved and assigns its resolved value to the variable resolved value. Then we log resolved value to the console. We're able to handle the logic for a promise in a way that reads like synchronous code. Instructions. 1. In the provided code, we've required in the function brainstorm dinner. This function expects no arguments and returns a new promise with a resolved value of a string representing a meal. You can look at the code for this function by navigating to the library.js file. Look at the native promise dinner function. That's right here. Take a moment to understand this function and predict its expected outcome. In the next step, you'll be recreating its functionality using async await rather than native promises. It's not necessary to execute the native promise dinner function, but if you'd like to, check out the hint for some guidance. You press check work when you're ready to move to the next step. Okay, so they want us to look at that and predict what it'll do here. We have the brainstorm dinner, native promise dinner, brainstorm dinner dot then. It's going to have a meal and console log. I'm going to make the meal for dinner. So it should just have a meal passed into here. Let's check the work. Oh, that actually just moves us to, oh, I see. They said check this hint here, and oh, they're just asking us to run the app. Okay, so we'll invoke this under it, and then we'll run it so we can actually see what comes out. Here we are, and then node app.js. I have decided what's for dinner. Should I make a salad? Okay. I'm going to make beans for dinner. That's what he's going to do. Okay, that's what we expected, and everything else that came out here came from this other library, the brainstorm dinner. Okay, let's go to number 2. Fill in the body of the announce dinner function so that it has the same functionality as native promise dinner. It should wait for the promise returned from brainstorm dinner to resolve, and then log a string to the console in the same format as did native promise dinner. You'll need to use the await operator inside your function. When you're ready, check your work and move on to the next step. So we need to do what is happening here. So what I would like to do there is let's make a const called meal, and that will equal await brainstorm dinner and invoke it. So that's what meal will equal. And then we could just go ahead and take theirs right here, console.log after that. And that should work. Let's check our work. That works. Let's go to number 3. At the bottom of app.js, beneath the function declaration, invoke the announce dinner function. Okay, so we're going to invoke this right at the bottom. Check our work. That's there. In the terminal, type node app.js and press enter to execute your code. Node app.js. All right, we are going to make beans again. A lot of beans for dinner. And we should check our work and we can move on to the next lesson. Writing async functions. We've seen that the await keyword halts the execution of an async function until a promise is no longer pending. Don't forget the await keyword. It may seem obvious, but this can be a tricky mistake to catch because our function will still run. It just won't have the desired result. We're going to explore this using the following function, which returns a promise that resolves to "yay, I resolved" after 1 second. Let my promise equal a fat arrow function, return new promise resolve reject, and inside the function body of the new promise is a set time out. A resolve inside of the set time out is set to "yay, I resolved," and it resolves in 1,000 milliseconds or 1 second. Now we'll write 2 async functions which invoke my promise. Async function no wait, and that let value equal my promise console.log value. The other async function yes wait lets value equal await my promise, and then console logs that value. No wait is going to print a promise, and it'll be pending. Yes wait will print yay, I resolved. In the first async function, no wait, we left off the await keyword before my promise. In the second, yes wait, we included it. The no wait function logs promise pending to the console. Without the await keyword, the function execution wasn't paused. The console.log on the following line was executed before the promise had resolved. Remember that the await operator returns the resolved value of a promise. When used properly in yes await, the variable value was assigned the resolved value of the my promise, whereas in no wait, value was assigned the promise object itself. Instructions. 1. Take a look at the provided code. We required in the shop for beans function from library.js, which returns a promise with a resolved value of a string representing a type of bean, e.g. kidney. Next, we declared the getBeans function. Let's summarize its intended functionality. Log. 1. Heading to the store to buy beans to the console. Capture the resolved value of the promise returned when we invoke shop for beans. The promise returned from shop for beans prints a string in the format 2. I bought the resolved type of beans because they were on sale. Finally, the function prints a string in the format 3. Great, I'm making the bean type beans for dinner tonight to the console. Execute app.js in the terminal to see if getBeans is working as intended. So we've been doing that with node app.js. And it is, well, that one's not working, and that one is. And it seems the second one happened after the third one here. So let's take a look. We could actually do check work, so we could see what they say about this. Okay. Get beans is logging 3. Great. I'm making object promise beans for dinner tonight to the console. Take a moment to understand why this is happening, and then refactor get beans so that it works as intended. Check your work when you're ready to move on to the next step. Okay, so we want to put async here in front of the function, and we're going to await this second value. And let's check the work, see if that's right. That is right. To test the code is now functioning properly, execute app.js in the terminal again. So let's do that again. That is working properly. And if you saw what just happened, like it just appeared on the screen, if you just press the up key, that's going to go through the last few things that you typed into your console in most consoles. So that's what happened there. Let's just check the work here. We're good to go to the next lesson. Handling dependent promises. The true beauty of async await is when we have a series of asynchronous actions which depend on one another. For example, we may make a network request based on a query to a database. In that case, we would need to wait to make the network request until we had the results from the database. With native promise syntax, we use a chain of .then functions, making sure to return correctly each one. Function native promise version, and this is exactly what we did in the last lesson when we talked about .then. Let's break down what's happening in native promise version function. Within our function, we use two functions which return promises, returns first promise and returns second promise. We invoke returns first promise to ensure that the first promise resolves by using .then. In our callback of our first .then, we log the resolved value of the first promise first value and then return second promise first value. We use another .then to print the second promise's resolved value to the console. Here's how we'd write an async function to accomplish the same thing. Async function, async await version, invoked as a function, and the function body says, let first value equal await returns first promise invoked, console.log first value. Let second value await equals await, return second promise, and inside of there is the first value, and then after that, console.log second value. Let's break down what's happening in our async await version function. We mark our function as async. Inside our function, we create a variable first value assigned await returns first promise. This means first value is assigned the resolved value of the awaited promise. Next, we log first value to the console. Then we create a variable second value assigned to await returns second promise with first value inside of the invocation. Therefore, second value is assigned this promise's resolved value. Finally, we log second value to the console. Though using the async await syntax can save us some typing, the length reduction isn't the main point. Given the two versions of the function, the async await version more closely resembles synchronous code, which helps developers maintain and debug their code. The async await syntax also makes it easier to store and refer to resolved values from promises further back in our chain, which is a much more difficult task with native promise syntax. Let's create some async functions with multiple await statements. Instructions. Take a look at the provided code. We require in 3 functions: shop for beans, soak the beans, and cook the beans. These functions each return a promise. Shop for beans expects no arguments and returns a promise which will resolve to a string of a bean type. soak the beans, expects a bean type string as an argument, and returns a promise which resolves to a Boolean indicating whether or not the beans are softened. Cook the beans expects a Boolean as an argument, and if that value is true, returns a promise which will resolve to a string announcing that dinner is ready. If you'd like, look at the library.js file to see how these functions work. Press check work to move to the next step. Let's move to that next step so we can start working on this async behavior. 2. In the following checkpoints, you'll create an async function that handles the 3 dependent promises we just walked through. It will simulate shopping for, soaking, and then cooking the beans. To get started, declare an async function, makeBeans. You can leave the function body blank for now. Check your work to move on to the next step. All right, let's make our async function makeBeans. And it's going to take in, oh, we could leave it blank, it says. Okay, let's check our work. Number 3, inside your function, declare a variable type assigned to the resolved value of shop for beans. This must be accomplished in one statement. Okay, so we'll do a const called type, and that equals await shop for beans, invoked like so, and let's check work. Great. Number 4. Next, inside your function, declare a variable isSoft, assigned to the resolved value of soak the beans. Don't forget, the soak the beans function expects an argument. Make sure to pass the expected value into soak the beans. Soak the beans wanted to know what type of beans. So we're going to put the type in there. So yeah, this will all be in order. So const, and they want us to call it isSoft will equal await, and then soak the beans. Inside of there, we're going to pass in type. And check that work. Perfect. Let's go to number 5. Next, inside your function, declare a variable, dinner, assigned to the resolved of cook the beans. Don't forget, the cook the beans function also expects an argument. Make sure to pass the expected value into cooked the beans. So a new const called dinner equals await, and this is called cook the beans, and inside of there it's going to have the isSoft passed in. At least that's what I think. Did they tell us anything different? It expects a Boolean value argument about if it's soft. Okay. So yeah, that should work. Let's check the work. Cool. Number 6. Next, inside your function, log your dinner variable to the console. Okay. Console.log dinner. Check work. Beneath your function declaration, invoke the makeBeans function. Okay. makeBeans invoked. Check work. Let's see your async function in action. In the terminal, type node app.js and press enter to execute the code. All right, it looks like it worked because dinner is served after all of that. Let's check that work and we can move on to the next lesson. Handling errors. When .catch is used with a long promise chain, there is no indication of where in the chain the error was thrown. This can make debugging challenging. With async await, we can use try-catch statements for error handling. By using this syntax, not only are we able to handle errors in the same way we do with synchronous code, but we can also catch both synchronous and asynchronous errors. This makes for easier debugging. They have an async function called using try catch, and inside there is a try block inside of the body of the async function. The try block has let resolved function equal await async function, and inside async function thing that will fail. Let second function equal await second async function, and inside of there is the resolve value, and there is a catch after the try block closes. The catch takes in an error, ERR, it opens a block, and it console.logs that error. At the end, it invokes using try catch. Remember, since async functions return promises, we can still use native promises.catch with an async function. And now we have an async function using promise catch. Inside of there is let resolve value equal await async function thing that will fail. Under that, let rejected promise equal using promise catch invoked. And then after that, rejected promise.catch, reject value, arrow function, console.log reject value. This is sometimes used in the global scope to catch final errors in complex code. Instructions. 1. For convenience, we've been working with a lot of promises that never reject, but this isn't very realistic. This time, we've required in a function, cook bean souffle, which returns a promise that resolves or rejects randomly. When it resolves, the promise resolves with a value of bean souffle, and when it rejects with a value of dinner is ruined. If you're interested, you can see how the function works by looking in the library.js file. Press check work when you're ready to move to the next step. Okay, well, let's move to the next step and work with this. Declare an async function, host dinner party. Inside your function, create a try catch statement. The catch statement should specify an identifier error. You can leave both the try and catch blocks empty. So we want to make a host dinner party, so async function, and we are going to do a try. That's our try. Then we'll have our catch, which takes in error. And we could leave the body empty. I think that's everything that it said there. Let's just check that. Oh, I didn't name the function. Async function, host dinner party. Going too fast. Let's check the work there. Perfect. Number 3. Inside your try block, log a string in the following format. Resolved value of cook bean souffle promise is served, i.e. bean souffle is served. Make sure to await the cook bean souffle promise. For more guidance, check out the hint. Okay, so this is in the try block, and we want to, about const res for resolve equals await cook bean souffle. And we can invoke it. And now we have to make this here. All right, let me just take this down. This is a console log, right? Yeah, log a string, console.log. And I'm going to try to do it with backticks here. So this whole resolved thing here gets replaced. And it gets replaced with, so we'll put the $sign so we can do our string interpolation, res, which is the result of awaiting cook bean souffle. Let's give that a shot and see if we were right. That's right. Number 4, let's fill in the catch block. First, log the error to the console, and then log the string ordering a pizza to the console. Okay, so just console.log error, and then after that, we can console.log a string that says ordering a pizza with an exclamation point at the end. And let's check that. Okay, great. Number 5. Awesome. Beneath your function declaration, invoke host dinner party. Okay, host dinner party is invoked. Check work. Number 6. Let's see your function in action. In the terminal, type node app.js and press enter. To run the code, if you keep executing app.js, you'll see the result of the promise resolving or rejecting. Okay, so node app.js, and we could run that code. And dinner was ruined that time, and if you just press up and enter again, yeah, there we go, the bean souffle was served. So we saw both results, we can check that work, and move on to the next lesson. Handling independent promises. Remember that await halts the execution of our async function. This allows us to conveniently write synchronous style code to handle dependent promises. But what if our async function contains multiple promises which are not dependent on the result of one another to execute? Now we have async function waiting right over here. It has a first value and a second value, and they both equal await a first async and a second async. Then they console.log the first value, second value. Now they have async function concurrent. Now it has a const of first promise and a const of second promise set equal to first async thing and second async thing, both invoked. Console.log await first promise, comma, await second promise. In the waiting function, we pause our function until the first promise resolves. Then we construct the second promise. Once that resolves, we print both resolved values to the console. In our concurrent function, both promises are constructed without using await. We then await each of their resolutions to print them to the console. With our concurrent function, both promises' asynchronous operations can be run simultaneously. If possible, we want to get started on each asynchronous operation as soon as possible. Within our async functions, we should still take advantage of concurrency, the ability to perform asynchronous actions at the same time. Note, if we have multiple truly independent promises that we would like to execute fully in parallel, we must use individual .then functions and avoid halting our execution with await. Instructions. 1. Take a look at the provided code. We require in 4 functions: cook beans, steam broccoli, cook rice, and bake chicken. These functions each return a promise, which will resolve to a string representing a part of a meal. If you'd like, look at the library.js file to see how these functions work. Press check work when you're ready to move on. All right, let's give this a shot. Number 2. Declare in async function serve dinner. Create 4 variables. Let's do that function first. So async function was called serve dinner. Create 4 variables. So the first is a const called vegetable promise, which should be assigned the return value of steamed broccoli. Okay, so this is vegetable promise that will equal steam broccoli. And we're going to want to await that. Starch promise, which should be assigned the return value of cook rice. Okay. All right, let's see. Const starch promise will equal the return value of cook rice. Protein promise, which should be assigned the return value of baked chicken, const protein promise equals await bake chicken. Actually, I don't think I should be doing these awaits since we're going to do them all together at the end. These variables should be assigned the promise objects themselves, not their resolved values. And that's exactly what I was just saying. I'm going to get rid of these 3 awaits. And let's check that work. No, that's not it. Oh no, I didn't do the last one. Okay, and side promise, which should be assigned the return value of cook beans. Okay, const side promise equals cook beans invoked. Now let's check the work. There we go. Number 3. Next, console.log a string in the following format. Dinner is served. We're having resolved value of vegetable promise, resolved value of the starch promise, resolved value of the protein promise, and resolved value of the side promise. Example, dinner is served. We're having broccoli, rice, chicken, and beans. You'll need to await each promise, but there are a few different ways you can accomplish the desired functionality. Check out the hint if you want some guidance. So we just saw this done in an array. Let's take a look. So what they did was await each one of them. Did they log them? Do they want them logged? Yes, okay. So we will console.log, and then we will await everything that we need to. So I'll put in my backticks, and the string is going to say dinner is served, period. We're having, and now we need the resolved promises. Await, and we'll await first the vegetable promise. Comma, and then we'll await the starch promise. Oh, I got the comma outside of that. Make a new one. Await starch promise. We will comma again, make a new string interpolator right here, and it'll be protein promise next. Await protein promise. One more comma, the word end, and then we'll open up another one of these, and we need to do the side promise. Await side promise. Check that work. Okay, now we have dinner is served. We're having vegetable promise. That's await vegetable promise. I did that. And there's a comma. Await starch promise. That looks to be exactly the same. And there's a comma, and it was at the right spot. Okay. A space, and then we await protein promise. And await side promise. Man, I forgot to put a period right here at the end. I think that's what did it. Let's check that work. Yeah, that was it. Those are painful sometimes where you just miss one thing. I could have been looking at that for quite a while. Number 4, awesome. Let's see your function in action. Beneath your function declaration, invoke serve dinner. Serve dinner. And we will invoke it, check my work, and then we need to, in the terminal, type node app.js and press enter to run the code. And it does work. Let's check that work. We passed, and we can move on to the next lesson. Await Promise.all. Another way to take advantage of concurrency when we have multiple promises which can be executed simultaneously is to await a Promise.all. We can pass an array of promises as the argument to Promise.all, and it will return a single promise. This promise will resolve when all of the promises in the argument array have resolved. This promise's resolve value will be an array containing the resolved values of each promise from an argument array. Async function, async prom.all. That opens up its body and has a const result array equals await Promise.all, Promise.all opens up and it has an array that contains async task 1 invoked, async task 2 invoked, these are with commas in between them by the way, async task 3 invoked, and async task 4 invoked. Now they do a for loop. For let I equal 0, I is less than result array.length I++, console.log result array I. In our above example, we await the resolution of a Promise.all. This Promise.all was invoked with an argument array containing 4 promises, returned from required in functions. Next, we loop through our result array and log each item to the console. The first element in result array is the resolved value of the async task 1 promise. The second is the value of the async task 2 promise, and so on. Promise.all allows us to take advantage of asynchronicity. Each of the 4 asynchronous tasks can process concurrently. Promise.all also has the benefit of failing fast, meaning it won't wait for the rest of the asynchronous actions to complete once any one has rejected. As soon as the first promise in the array rejects, the promise returned from Promise.all will reject with that reason. As it was when working with native promises, Promise.all is a good choice if multiple asynchronous tasks are all required, but none must wait for any other before executing. Instructions. In this exercise, we require in the same 4 functions as in the last exercise: cook beans, steam broccoli, cook rice, and bake chicken. These functions each return a promise which will resolve to a string representing a part of a meal. You can check them out in the library.js file. Press check work to move to the next step. Let's see what we need to do here. Number 2. You're going to create a very similar function to the serve dinner function you created in the last exercise. This time you'll use Promise.all. Create an async function, serve dinner again. Let's do that first. So it was async function, serve dinner again. And in the body of that, inside your function, declare a variable food array and assign it the resolved value of the promise returned from Promise.all. Okay, so let's make a let food array equal await Promise.all. Inside there, we're going to open up an array. And remember that Promise.all takes in an array of promises. So we're going to pass in all of these promises. Pass in an array containing the steamed broccoli, cooked rice, baked beans, and cooked beans. So steamed broccoli, and invoke it, comma, to cook rice, and invoke it, comma, to baked chicken. Invoke that, and finally the last one's just cook beans, and invoke that one. I will do the semicolon here just to clear that. I think we did that properly. Let's check that work. Yeah, that's right. Great. Move on to number 3. Next, console.log a string in the following format. Dinner is served. We're having first item in food array, second item in food array, third item in food array, and fourth item in food array. Example, dinner is served. We're having broccoli, rice, chicken, and beans. There are a few different ways you can accomplish the desired functionality. Check out the hint if you want some guidance. Okay, so now we know we have an array that contains everything here: broccoli, cooked rice, baked chicken, and beans. And they just want the items in the array from first to fourth. And they want it to come out like this string. Okay. I'm guessing they want it inside the function, of course. Console.log And the first thing we'll write is where having. You know what, let's do the backticks way. That is a nice way of doing it. Backticks, then where having. And actually before that I didn't write dinner is served yet, so dinner is served. Yeah, dinner is served, period. We're having broccoli, comma, okay, so we're having, and then we will space, we'll do our string interpolating right here for the first element in the food array. So food array at 0, because these are 0 indexed. And then we'll comma, we want the second element, so we'll do the same thing again, 2 more times it looks like. Food array at 1, comma again, the third element, okay, so same thing one more time. Food array at 2, and we comma, we write end, then we'll open up another one and do our last food array piece. Food array at 3. And let's see if we did that right. We'll check that work. And what did I do wrong? I probably didn't put a period. Yes, I didn't put a period at the end. A habit of mine. Okay, I'm gonna look up here to see if I did anything wrong. Oh boy, I actually just saw it. Okay, you probably saw this and already corrected it. Food array. That's got to be it, I'm guessing. Yeah, that was it. Just a little typo there. Number 4. Okay, great. Now let's see your function in action. Beneath your function declaration, invoke serve dinner again. Serve dinner again, invoked. Check the work. In the terminal, type node app.js and press enter to run the code. Node app.js, enter. Dinner is served. We're having broccoli, rice, chicken, and beans. And check that work. Let's move on to the next lesson. Review. Awesome work. Getting the hang of the async await syntax. Let's review what you've learned. Async await is syntactic sugar built on native JavaScript promises and generators. We declare an async function with the keyword async. Inside an async function, we use the await operator to pause execution of our function until an asynchronous action completes and the awaited promise is no longer pending. Await returns the resolved value of the awaited promise. We can write multiple await statements to produce code that reads like synchronous code. We use try-catch statements within our async functions for error handling. We should still take advantage of concurrency by writing async functions that allow asynchronous actions to happen in concurrently whenever possible. They mean concurrency. So they're saying take advantage of concurrency so that async actions will all happen at the same time. Great, let's see what's up next.